Periodic Table and Periodicity, Chemistry by Hassan Malik. What is the periodic table? The periodic table is a chart that organizes all the chemical elements. These elements are the basic materials that make up everything in the world. Example, elements like oxygen, which we breathe, and gold used for jewelry are all part of the periodic table. What are elements? Elements are pure substances made out of one type of atom. Each element has its own unique properties, like how it looks, how it reacts with other elements, and whether it's a solid, liquid, or gas. Example, water is made up of two elements, hydrogen and oxygen. Why is the periodic table shaped the way it is? The periodic table is organized by atomic number, which tells us how many proton/electron an element has in its atoms. The rows and columns show patterns in how elements behave. Example, elements with similar properties are grouped in columns, like the noble gases, which don't easily react with other elements. What is periodicity? Periodicity means that elements show repeating patterns or properties as you move across or down the periodic table. These patterns help scientists predict how elements will react. Example, as you move from left to right across a row, elements tend to get more reactive. The less reactive, this pattern repeats for each new row. Groups and periods. The periodic table has groups and periods. Elements in the same group have similar chemical properties, while elements in the same period have increasing atomic numbers. Example, group 1 contains alkali metals, which are all very reactive, especially with water. Metals, nonmetals, and metalloids. Elements are divided into metals, nonmetals, and metalloids. Metals are shiny and conduct electricity. Nonmetals don't conduct electricity well, and metalloids have properties of both. Example, copper is used in wires because it conducts electricity, while carbon is used in pencils. Metals, nonmetals, metalloids, or semi-metals. Why is the periodic table important? The periodic table helps scientists understand how elements react and combine to form new substances. It's like a map for exploring the world of chemistry. Example, chemists use the periodic table to predict how elements will interact when creating new medicines or materials. The first periodic table. The first periodic table was created by a scientist named Dmitry Mendeleev in 1869. He organized elements based on their atomic weights and noticed patterns that no one else had seen before. Example, Mendeleev even predicted elements that haven't been discovered yet, and he left spaces for them in his table. Discovering new elements. Scientists are still discovering new elements. The last row of the periodic table contains elements that were created in laboratories and have very short lives. Element 118, called organicid, was discovered in 2002 and added to the periodic table in 2016. Noble gases, the cool kids of the periodic table. The noble gases in group 18 are called inert because they don't easily react with other elements. This makes them special. Example, helium used in balloons because it doesn't catch fire or react with anything, making it safe to float around in. Periodic trends. As you move across or down the periodic table, certain trends appear. For example, elements on the left are usually more reactive than those on the right. Example, sodium on the left reacts explosively with water, while helium on the right doesn't react at all. Atomic size. Atomic size refers to how big an atom is. It depends on how far the outermost electrons are from the nucleus. As you move down a group in the periodic table, atomic size increases because more electron shells are added. Example, hydrogen is a tiny atom, but cesium is much bigger because it has more electron layers. Ionization energy. Ionization energy is the amount of energy needed to remove an electron from an atom. The higher the ionization energy, the harder it is to remove an electron. It increases across a period and decreases down a group. Example, it's easier to remove an electron from sodium than from neon because neon has a higher ionization energy. Electron affinity. Electron affinity is how much energy is released when an atom gains an extra electron. Atoms with a high electron affinity really want to gain electrons to become more stable. Example, chlorine has a high electron affinity because it easily gains an electron to become stable, while noble gases like helium have no electron affinity because they don't need more electrons. Shielding effect. The shielding effect refers to how inner electrons protect outer electrons from the pull of the nucleus. More inner electron layers weaken the attraction between the nucleus and the outer electrons. Example, in potassium, the outer electron feels less attraction to the nucleus because it's shielded by many inner electron layers, making it easier to lose. Electronegativity. Electronegativity is how strongly an atom attracts electrons in a bond. Atoms with a high electronic negativity pulls electrons toward themselves more strongly. It increases across a period and decreases down a group. Example, fluorine has the highest electronegativity, so in a bond with hydrogen, it pulls the shared electrons closer to itself, making the bond uneven. I hope you enjoyed the video and thank you so much for watching.